Hi, TSFrames is a Julia package for doing time series data manipulation. Now, the motivation behind this package is to provide convenient interfaces and code reuse. The convenient interfaces provided by this package are built on the Zoo and XGS packages in R. These packages have been developed over the past almost 2 decades by Ahim Zylis, Jeffrey Ryan, and others, and have become sort of the standards in providing API for doing data manipulation for time series. Now, how does TSFrames achieve this? So, TSFrames is built on top of TSFrames.jl at its core. TSFrames.jl is very mature. It provides extensive functionality. So TSFrames builds on top of this by providing thin wrappers. So we're going to look at a very common finance problem. We're going to download stock price level data. We're going to subset it for a time range. We're going to compute log returns, change its frequency to weekly, do some plots, and do some rolling window operations and aggregations. So let's see how we do it with TSFrames. So the GitHub URL of the package is given here, and then the tutorial which I'm conducting here is going to be present on this demo URL. So how do you install the package? Using package.add TSFrames. It's a registered package, so you shouldn't have any problems with that. Now we are going to import some libraries. After importing TSFrames, we are going to import market data. We will use market data to download time series data directly from Yahoo Finance. Then we will use impute.jl package to fill in the missing values, GLM for running regressions, and plots for doing the plots. So the first step in any data manipulation exercise is to download the data, and here we are using marketdata.yahoo. We are downloading the daily stock prices of IBM, and then in the second line, we convert the data which we got into a TSFrame. Here you can see the data contains some 13,000 rows and 6 columns. Similarly, we will download data for Apple, of the Apple stock, convert it into a TSFrame. Because TSFrames.jl supports tables.jl interfaces, so you can directly convert from a time array which is returned by marketdata.yahoo into a TSFrame. So now we want to work with this year's data. So TSFrames provides a function called subset, wherein you provide the start date and the end date. So we take the start date as the first day of 2023 and the end date as today. We do it with both the data sets. All right, so now we take the adjusted closing prices of IBM and Apple. This gives us 2 objects, IBM underscore adjust close and Apple underscore adjust close. Both of them have a single column. Now we insert the missing values using the impute library. So the LOCF function here, what it does is to insert wherever there are missings, it will take the last observation and carry it forward. So it will just copy paste the last observation in the places where there were, if there are any missing values. In this data, there are no missing values as of now, but this is a safety check which you have to do. Okay, so we have executed this. After this, we do the join. So now we combine the IBM prices with the Apple prices. And what we do is, so this is done by the join function. But what we do is we take the join type as join both, which means the intersection. So this again follows the TSFrames.jl methodology of so all the package supports this join function supports all the join types which are provided by TSFrames.jl, like join all, join left, join right, and etc. So we combine both these into one single object. All right. And so now we rename the columns so that we know which prices are in which column. All right. So now we have a single, we have a matrix of the dates and IBM and Apple. So now we have a matrix with two columns for IBM and Apple prices. The next step in our in this example is that we convert this data set into a weekly series. So to_weekly is a convenient function which is provided by the package to convert any time series object, a TSFrame object, into a weekly series. So now we have the weekly series. We compute the weekly returns by doing the diff log. These are log returns. Then we again rename. Okay. So one of the common operations in finance is to compute standard deviation of weekly returns. So we do it for both IBM and Apple. Okay. So we have the standard deviation numbers. Okay. So now the next step is to do a scatter plot of Apple and IBM weekly returns. TSFrames uses the plots package to implement this plot. So you can directly call plot on a TSFrame object. And here is the scatter plot. One of the other common operations in for time series objects is to do aggregation and rolling window operations. For that, TSFrames.jl provides apply and roll apply methods. So let's take a look how they work. We compute the daily returns again for IBM and Apple. Then we compute the realized volatility, which is essentially for a week. So within a week, what was the standard deviation for each week? So if you see the apply operation takes the first argument as the times TSFrame object, then the period on which we want to compute the standard deviation, right? And the third argument is the function itself, which is std here. So let's do this. Okay. So we have the week on week, the standard deviation of each week. This can also be, we can change the period to month also. Right. So let's do that. So if we change this to month, yeah. So here you can see that it's given us the standard deviation for each month. And this can also be changed to, the frequency can be changed to like every 2 months. So that, so this is what the result is. And so now we look at the roll apply function. So this is primarily used for computing rolling means and rolling volatilities. So here what we do is again provide the TSFrame object, provide the function and the window size, which is the third argument. The fourth argument by column equal to true, it is the default. I'll tell you later why, where, in which cases this is used. So let's just compute on the. Okay. So as you can see here, it's taken 10 rows and computed standard deviation and done it on a rolling basis. So then it's moved to the next day. It's taken from first row to the 10th row and then moved from the 11th, second to the 11th row and third to the 12th row and so on. So another common operation in the finance domain is to do rolling regressions. So here what we are doing is we are going to take S&P 500 values and then we are going to take IBM price returns and S&P returns and then run a regression over a rolling period. So again, we download the data from Yahoo Finance, okay, and then directly in one line we subset the data for 2023 and take the adjusted closing prices. Right? So here we go. We join the S&P 500 values with the IBM values and we compute the log returns, do the rename, and this is our regression function. We take S&P 500 as the response variable, IBM as the predictor, and return the coefficient and the standard deviation of the residuals. So this is what we do. It's a simple function. Then we again use roll apply, provide the returns, provide the function name, the window size, and this is where by column comes into the picture. We do this because we want to run our own function and the column names of this of the data are part of the function itself. So you can see that we are running a regression here. We are providing the column names. So that is why we are saying by column equal to false, so that when we run this function, the whole TSFrame object goes into the function. If we do by column equal to true, then the function is run on each column and we lose the column names. So this is the difference between by column equal to true and by column equal to false. So let's run this. And here is the result. So as you can see, doing very common time series data manipulation is pretty easy. The functions are pretty simple. You provide the TSFrame object, you provide some arguments, and you get the result while following the Julia convention, and you get this the speed of Julia for free. In some other languages, it's a little more difficult to do these kind of manipulations. And this is where we thought that the Zoo and XGS of the R community is sort of pioneer in the field of time series data manipulation, and they are the standard of the API which is used to do these kind of manipulations of time series data. So thank you.
So it's not just syntactic sugar. So it's not just syntactic sugar on data frames. Some of the algorithms are different because if you have sorted data, then you can merge things faster. So those things are also being done. Yeah, now I'll try to answer if there are any questions.
The question that I have for you regarding the regression that you showed. Now, for many applications, I'm not a finance person, so I can't really speak to that, but for many applications, specifically, we need to retrend and then we run what is called a
Yeah. So, so in this case, there'll need to be a different package for Arima. I mean, I think that's how the Julia ecosystem is, that every small thing turns out to be a separate package, and this is just focused on the manipulation part. So it won't have. For example, we use the GLM package instead of having the regression ourselves. So we would have the Arima being imported.